Okay, good morning, class. I think we are recording appropriately here. Let me make sure this thing is recording. Yes, I am recording. So I think we're in good shape. Um, this video is going to be about how to use the Carrier hourly analysis program, which I have fired up here on the screen. I guess I can demo how to open it. That's pretty easy. We close it and you go down here and you find Carrier ECAT E20II programs. Click on that. And it's the hourly analysis program we want, 5.11. We click on that. And if we have it installed properly, we should be good. Say okay to these things. These are some models that I put on this computer. This is my new computer, so I don't have, I've got SCADs on the old one, and these are the only ones I have transferred over. So this is the model that I emailed you guys. So I'm going to just open it from this dialog box. Now, when you guys first start, what you'll need to do, those files that I sent you, you don't want to do an open on those. What you want to do is download it, put it someplace on your computer that you can find it. You can leave it in the download folder if you want to, but you just click project and you want to do a retrieve project from file. When you transfer models from one computer to the next, you don't want to use save and open. You want to use archive and retrieve. It's a little, when you archive a file, it saves more information than if you simply save it. There's some background information that if you're going to use that, build that model and use it only on your computer, then you can save and open works fine. But if you're going to transfer it from one computer to another, you want to use archive and retrieve. And I think it includes weather data and other aspects of the file that are resident on your system and are always there if you use the open and save. But when you archive it and take it to a different computer, or when you want to move it to a different computer, you want to use the archive and then retrieve it from the archive file on the new computer. So, having beat that horse for a while, we'll move on. Okay, so this is the operating, the main screen, where kind of the general operating position when you open the program. This is where you come to. And so we've got a lot to talk about here. I don't know if we'll get everything done in this video or not. We'll see. There's no magical sequence to this. I'm going to take you through in the order that I typically do. So let's see, I would click on weather. And you know what I may do? Let's just do a new file right now. And this is going to be, we'll just make up a building or something. And so this has to do with the preferences. The ASHRAE standard 62 is the ventilation. If you're doing this for LEED certification, which we're not messing with that right now. So, and this is the energy standard, ASHRAE 90.1. You can just accept this. This is not a problem. So, okay, so let's say we can just give this thing a name. We'll just call it test, and we'll save it away. So, okay. next thing I usually do is I'll go to weather. If you start from default, it defaults to Chicago, Illinois weather file. So let me double click on this. Double click again. There we go. There's the weather tab. Now, what you'll see is this first tab. This is design parameters. We've got design temperatures. We've got design solar, and we've got simulation. So there's actually two weather files that you have to call up in order to do everything that the program is capable of. So under design parameters, this is the weather file that gets used for equipment sizing, which is kind of one reason to run the program. The other reason would be annual energy simulations, and that tab says simulation weather, and so you have to call up a file here as well if you want to do annual energy simulations. In your assignments that you're receiving, you're going to get to do both, so you need to put a weather file in at this tab and this tab as well. So under the design weather, I mean, it's pretty obvious. You've got region, USA. You can just pull, if you do a pull down, they've got weather files from all around the world. So, but we're going to go US of A, and then you're going to pick your state. So we'll go down and find Tennessee. There we go. And then you pick a city in Tennessee. So probably Nashville is the closest to Cookeville. So that will be fine. These are all default values that come out of that weather file. If you want to change them, you can. I don't necessarily recommend it, but I mean, it depends on your purpose for running the program. We're just, for now, we're just going to accept all of these. So we don't have to change any of this, even though you can. And then I'm going to go over to the simulation tab. And here I'm going to select, they've got a whole bunch of these things built into the program. You can import weather files. I've never really done that. I've always been able to find, what I thought was an acceptable file from the library. So I'm going to click on that. And my goodness, you're struck by just how many files from all over the place. We've got Argentina, Aruba, Australia, and they're in alphabetical order, country first. So USA, I'm going to go on down to Tennessee, and there's Nashville. You can click it once and open, or you can double click it. And then, so it has it. TM2 is, I believe that stands for typical meteorological year of type 2. Get into all of the climate modeling and how they put these files together. And there's different standard formats, but there's a whole industry built up around doing weather modeling and putting together files for simulation purposes. Okay, so I'm going to select that. So I've got my weather set up. Next thing, I'm going to jump down here to this folder, project libraries, and I'm going to go down through a lot of these items. So under schedules, and then it shows up over here, and then I'm going to double click on that. Okay, so we actually have different types of schedules. We schedule things. We schedule all sorts of stuff. We schedule lighting on and off. We schedule occupants, number of occupants in a space or a zone or different portions of the building. And we schedule occupied and unoccupied hours in terms of the thermostats. We also can schedule the time of day for different utility rates. Some rate structures will have a on-peak period and an off-peak period. And so you use scheduling quite a bit. And this is something that, it's just something you have to get set up, hopefully correctly as you start a new model. This is usually on the front end, but sometimes you make modifications in this. So I'm going to call this an occupant schedule. Okay. And so most schedules, it tells you here, lighting, people, equipment, etc., are fractional type schedules. So that's the type that I'm creating. I'll go over here to the second tab, and I've got 8 different occupant profiles. And so a typical situation might be that I would double click on this, it brings it down, and you can give this a name. I'm going to call this a weekday. Okay. And so now this fraction or percentages. You really put them in as percentages. I think it uses them in the code as fractions. But so you see we have from midnight until 2300 in the morning down here. And what we do is when you define a space, you put in that space definition the maximum number of people that can be in there. And then for each hour of a weekday, you put in the percent of that maximum that's actually present. Okay. So let's say this is maybe a small office building or something. And so there's nobody there from 0. Let's see. There's different ways to do this. The way I usually do it is I'll put, say, 0 to 6. I'm going to say there's nobody there. Okay? So I put 0-6 and I hit 0, and it takes the bars down. You can grab the bars individually and move them if you want to. That's somewhat painstaking, but if you want to adjust 1 or 2, you can grab them and move them, or you can put them in like this. So then I'm going to say so I've got through 6, so then I'm going to go 7 through 8. I've got a bunch of sleepy heads, so maybe I've got 50% of the people there. And then from let's say at 12 o'clock, a lot of people go home for lunch. So I go down to 75%. And then 1 through I don't want 1. This military time tears me up. That's 12. Well, we'll say everybody's back at 13. 12 and 5 is 17. So I'll say 1800 through 20. About 30%, and then 23. Maybe they're cleaning the building, and I have 10%. Okay, something like that. Anyway, that's a profile. Okay. So let's see. I think I can just double click on this one. See, let me say okay. Go back to this, make sure that got saved. Yeah, it's there. I'll do one more. I'll just say weekend. And I'm going to say there's basically nobody there. 0 through 23. Oh, well, we'll put, let's put 5%. Let's see. There's some overachiever in there. Okay. All right. And so we have an occupant schedule. And then if say I want to do one for lighting, Okay, and so I can either go up here or I can right click. I can duplicate this. Lights, I'm going to do a new one real quick. So we'll just call this lights. Okay, and it's fractional. And I go to profile. And we'll say we're just going to leave, let's say this is, again, weekday. And we'll go 0 through 6. And we just leave, say, 10% of the lights on at night. And then we'll say, 21 through 23. I'm just trying to get something in here. People are still cleaning, but they got most of them off. Okay. And then here, this is weekend. And we're just going to go 0 through 23. We'll say we keep 10% on the weekend. Okay. So we got lights occupant. Let's say that we need an equipment schedule. So I'm just going to right click on this one and say duplicate, and then we'll change the name to equipment. And it's fractional, and so it's going to be the same. So I'm going to say that's okay. And we'll need one for, we'll need a thermostat schedule. So we'll call this T-stat. And thermostat. Okay. And I'm just going to leave this. Well, let me show you how this works. So we'll just say, oops. Okay, so it wants me to select it before I name it. Okay, well, I'm trying to mess up here, so. Okay, so this one, you're telling it whether the building is occupied as far as thermostat settings are goes, or unoccupied. And so, we'll say this is 0 through 5, and I'm going to say we're on. Well, no, I'm going to leave it occupied the whole time. Yeah, that's fine. So what this occupied means that we get different thermostat settings for occupied and unoccupied. And so right now, this is something I can run as a project to go from keeping the building up to temperature 24 hours a day to going to, say, an automatic night setback with setback thermostats. So I'm just going to go ahead and say that's fine. Oh, I know. There's one other thing I haven't shown you. Oh my goodness, can't believe I forgot this. The assignments. Ooh, forgot about this. Okay, so this is back to, this is the equipment tab. And so design, this is for equipment selection. So whatever thermostat schedule you want to be used for equipment selection, you put in that first row. And so that's, you put in a number for every month of the year. So one is fine. And then the rest of them are used for annual energy simulations. And so, and it's, you can click and hold and change a whole bunch of them at once. So Monday through Friday, I want my weekday schedule, which is number 1. So I'm going to hit a 1 for that. And then the rest of the time, Saturday, Sunday, and holidays, I'm going to let that be a weekend type schedule. And that's a 2. So that's okay. I need to do that on all of these lights. Let's see, we're going to do Friday ones, and these guys are twos. Okay. And occupant schedule, assignments. That's fine. We'll just do the same. And I mean, you can be as flexible as you want to on this, but you've got lots of opportunities to, you can put bunches of schedules and all. Two. Okay. And we'll just keep this. Well, let's see. This is on all the time, so they're all the same, so it doesn't really matter. But so we'll go ahead and do what we've been doing just for the heck of it. We may come back later and make some changes in this. Okay. Okay. So that's got the schedules. That's a little bit of a lengthy discussion. Time out for a coffee sip here. All right. Okay, so walls, we have to define what the exterior walls look like. It comes up with some sort of a default construction you can see here. Then it has some kind of generic types, very lightweight. You click on that, you can see basically that's a metal building. You got steel siding, you got 3 inches of insulation, you got more steel siding. Now, you can start out with one of these, and then you can change it. So if you click on the tab, it has a materials library. It's not exhaustive, but you know, it's probably good enough. And so, and notice we're starting from the inside surface. So we have a convection coefficient. The resistance, which is what 1 over the conductance, is 0.685, and then on the outside surface, the resistance, that's the convection coefficient, is 0.333. And again, I don't know. Yeah, you can change these. Anything? Yeah, you can change the number if you want to, for sure. So I don't know that you really want to, but you know. Whatever. You can, if you come over here and you right click, you can insert or remove. So if I'm gonna, you see when I get in that little box, I get that little arrow pointing to the right. If I right click, I can insert another layer, and then I can define what that layer is. So I don't really want to do that, so I'll take it back out, remove. Okay, so that's the very lightweight wall. You can go down to a heavyweight wall, and this is going to be 3/4 of an inch of gypsum plaster, 8-inch heavyweight concrete block, insulation, face brick. So this is pretty similar to, well, potentially. I was thinking the walls of Brown Hall. I'm not sure that it could well be concrete block. You know, I'm not sure. It's got brick on the outside. We know that much. Where you find this out really is you look on the architectural plans. If you go up to a building and you don't know, sometimes you have to guess a little bit, or somebody that's a maintenance person sometimes will know. On a house, it's sometimes a little hard to tell, but anyway, you can assume typical construction, or I guess you can drill a hole, cut a hole in the wall, look and see how it's made. Anyway, so we need to select some sort of a wall type. So let's see. And you've got all kinds of options here. I don't know. I'm just going to pick something. Let's do face brick, just to pick. And so it has that ready. So I've got walls, and now I have to select a roof. And same situation, you need to know how your roof is constructed. Now this is not where we define pitches or something on a roof. This is just a, you know, what are the layers that make it up? And it's a similar situation. So I'm just going to select a medium weight roof, which is what we've got: 2 inches of heavyweight concrete, insulation, felt membrane, slag or stone. So whatever you have. Okay, so it's got that. Then we have to define our windows. So again, double click. Now, as far as naming the window, I usually put the dimensions of the window in the name. I found over the years that that's a pretty handy practice. So I'm going to call this a 3 by 5 double pane. Okay. And of course it is 3 by 5 or 5 by 3. It doesn't really matter. But if we, you can make it whatever size you want to. And then for detailed input, you check the box and it brings it, turns on all of these different additional inputs. So here you can put a frame type. So aluminum with thermal breaks. Thermal breaks is a way to insulate the window frame. We'll talk about that in class. It takes a few minutes to describe. Internal shade. You can put, if you've got drapes or something like that, but I usually don't. And the rationale there is that, they build this building and they may be going to put drapes in it, but, 2 years later, they might decide to take them out. And so, if you put drapes, that will reduce the solar gains, which could lead you to smaller equipment, which when they take the drapes out is not adequate to cool the space. So, now if you're doing annual energy simulations and you want to try to match a utility bill and they have drapes and they use them or they have blinds, you might want to put that in. So again, you can adjust the inputs based on what your purpose is in running doing the simulations. But anyway, so I'm not going to put those in. Here I've told it it defaults to double pane glass. If you had triple pane, you could use this. You have different types of glass, and the airspace between the panes you can fill with argon or krypton or whatever. So I'm not, those are more expensive. They're better type windows, at least until all that stuff leaks out, but I'm not going to change that. So this is pretty good. So I'll just select this. Okay. Again, I have doors, which I can put in if I want to. I can say front door. Front door, gross area, maybe it's 4 by 8. I'll say 32. U value, I don't have I can put a window in it. I can also indicate that this might be shaded all day. Maybe it's on the front porch and the sun really can't get to it. And so, but if that's the case, okay, so I've defined a door. Let me show you this. Shade, if you have external features that shade portions of the building from the sunshine, you can indicate that here. Now, another thing that we can do, if we highlight an area, and I think it's F1. Let me see if I can get this thing to work. No, it didn't work. There we go. This new computer, I've got to hit F1. I got to hit function F1. But this pulls up the help, and it usually, well, I guess it didn't. Sometimes if you clicked on a space and you hit this, it goes right to that. But search. Let me put shade in. And it takes you to information overview on exterior shade. So the help is built into it, so you don't have to go look into a particular manual. You just hit get to function F1 and it brings it up, and then you can find it. It's really pretty good. It'll give you if you dig through here, you can find pictures of how it defines various parameters. That's really quite good. I find this overhang dimensions. Wow, yeah, I guess we're going to get the same picture here, but anyway, so we can close that. Now we're back to the program. Chillers, cooling towers, boilers, we'll go through those a little bit later. I think I may do another video after I get through just the equipment selection portion to keep them from getting too large. Electric rates, we have to tell it, if you're going to do energy simulations, you have to tell it how to value the electricity. You can do simple rates, which I'll just say test rate. Test rate, simple. And really, you don't have to put in much. Of course, it's not very complicated. Let's just say we're paying 10 cents a kilowatt hour, and our tax rate is 7%. That's really all it takes on a simple rate. So I'm going to say OK, and then we can do. Let's just click around for a second. If you do complex rates. This is where we get into the energy charges, the demand charges, and any demand clauses. We can do time of day scheduling, and then you have to tie that to a schedule that you made. So I'm not going to do that right now, but we will. We will probably get to that level of complexity before long. Okay. So, and then I've got fuel rate, and this would be for natural gas. I'll just go in gas rate test. And again, this is, if it's simple, it's really easy. There are 10 therms. A therm is 100,000 BTUs. So there's 10 therms in a million. I'm paying about $9 per million for gas, so I'm paying about 90 cents a therm at my house. I'm going to put 0.9, and we'll go ahead and put 7% tax on this guy too. Okay. All right, so I've got fuel rates for later. Okay, so and now I can define a space. So I'm just going to make up a box of a building. So this is going to be test building. We'll say this is what 5,000 square feet, ceiling height 12 feet, construction. You can pull the slider bar, or you can put a value in. I'm going to say 100 pounds per square foot. We can talk more about that later. The more massive it is, the more it's like a cave. The lighter construction, the more it's like a metal building. Okay, so then this is ventilation. This is where we put in our ventilation air, so we can pick a particular public retail. What's a good one? retail sales. We'll just make this a retail building. And then it puts in, it goes to the ventilation code and pulls out some values. It's going to put 7.5 CFM per person plus 0.12 CFM per square foot of area. And that's how it's going to determine the ventilation air that goes into this. Okay, so that's the first tab, internals. For lighting, overhead lighting, I'm going to say they're free hanging. They're just hanging out in space. I can put in now a total number of watts, or I can put in watts per square foot. It's going to default to 1. That's probably pretty good for commercial retail space. And then I have to put in a schedule, lights. I can put in additional task lighting if I want to, like desk lamps or, additional lighting on displays, whatever. I'm not going to do that right here. I'm going to put in a little bit of equipment. This is 5,000. We've got 5,000 square feet. So if I put in, I'm going to put in 0.2 watts per square foot. So that'll be 0.2 times 5,000 will be the number of watts. That's probably okay. And that's my equipment schedule. Hopefully I'm busy. Maybe I've got 25 people. That's not much for 5,000. Let's put 50 people. And they're doing not much, walking around shopping. So, you pick their activity level and it adjusts the amount of heat, sensible and latent heat that goes in. And so this would be occupants. And you can, if you have other heat that's generated, you can put in sensible latent heat. And I don't have any for that. Okay. Let's put in some, this is exterior walls. And so I'm going to have some that, whatever direction the wall faces. So I'll say I've got north. And I don't know, let's see if I got 5,000 square feet, so that's about 70. So I'm going to say this building is what, 100 times 100 by 50. And I'll say the walls are 15 foot high on the exposed side. So what I say, yeah, 100. So this would be 1,500 square feet. I've got windows. Let's put in, let's say I've got 8 windows in that wall. And I've got 1 door. Okay. And then I can put in, say my south is the same. 1,500, I've got 8 more windows and I've got a back door. And then on the east, was what, 50, what was that? 50 times 10, that's, yeah, that's right. That's 750 feet. We'll say I've got 4 windows, no doors, and on the west, I've got 750. I've got 4 more windows. Okay, so that's pretty good for the walls, windows, and doors. Roofs, I'm just going to put a flat roof on it. I can, let's see. So I can put in areas and slopes and degrees. I'm just going to say this is H for horizontal, 5,000 is good. It's got my only roof type. I can put in skylights if I want to. Infiltration, this is air that's leaking into the space, directly from doors, windows, cracks, people, opening doors, and wind blows in. I can either estimate CFM or air changes. From experience, I'm going to use about 0.2, and that says that's 200 CFM. And that's air changes per hour. So an air change would be the volume of the space replaced with infiltration air. Okay. I usually click this all hours. What this, if you click this top one, when it calculates that the fan is running on the HVAC system, it zeroes out the infiltration. If I'm going to put in infiltration, I typically want it to be there, so I leave that clicked. Okay, floors, this has to do, you know, is it slab on grade or is it above unconditioned or conditioned space? For this, I'm going to do slab on grade. And then this is exposed perimeter, which is going to be 200. It's 100. The rectangle is 50 by 100. So that's 100, 200. That's 300 feet. And I don't have any insulation. Okay. Whoops. I always forget this. What is it? Oh, it didn't find a door type. Oh, front door. Okay. There you go. It didn't see the door type. Okay. Oops. Huh. I don't know. Oh, this is interesting. Well, let me define another one. Test door. Oh, I had one. Maybe I didn't save it. There we go. I guess not. I don't know. I didn't like that other one. Okay. So now we need to put in HVAC system. Okay. So we'll just call this test system. And equipment type, we'll just, let's just put a rooftop unit on this guy. Constant air volume signal zone. We got a lot to talk about here, but let me just, these are kind of the standard components. You can put an economizer in by clicking this box. You can put in these other components by checking the boxes. Let's see, so airflow, we just do constant ventilation. This is fine. Nothing much on this tab. So let's see, we need to go to the different components. That's ventilation there, central cooling. DX, that means it's not chill water. That's fine. That's what the rooftop unit's going to be. Central heating. We'll put natural gas in it. This is if you want to disable it, say heating for a month of the year, which we don't. This is all pretty good. Supply fan. You have to give it, you have to put something in here to get fan energy. Total static, I'm just going to do 1 inch. And that's pretty good. And then duct system. You can have leakage. I usually go like 3%. Some heat gain in duct leakage, 3%, just to have something in there. Ducted return is fine. Okay, so let's see, spaces. We have to put our space in the building. So we'll do that. Thermostats, these are our thermostat set points. So this is occupied and unoccupied heating and cooling. And so we got to put our T-stat schedule on or it will complain. Supply terminals, we don't have to do anything there. Okay, so we have a system. Now, listen, to run it, we're going to highlight the system and we're going to right click. You right click, print view design results. This is design as equipment sizing, and that's what we're doing here. So these are all the different reports that you can get. These are fine with me. You should check all these boxes and look at it a little bit. And you just say go, and there we go. So this is the first report that we requested. We see 5,000 square feet. We've got 9.2 tons. We've got square feet per ton. We've got 544.6. You know, that's okay. That's a reasonable number. So we've got total capacity. We've got sensible and total. So the difference would be the latent capacity. This is cooling on the heating side. The peak heating it sees is 144,300 BTUs an hour. This is what it sees on approximating the airflow, the supply airflow needed. And this is the ventilation data. So another report, this is the one I like. This shows a detailed breakdown on the loads. Where's, I'll say our cooling load, where's it coming from? Well, we see we've got windows, usually pretty big. That's the total square footage that it sees. Wall transmission, that's heat conducted into or out of the building through the walls. Roof transmission, etc. So this is these are what happens in the zone, in the space itself, and these are loads that like the ventilation load appears at the unit. And so we can see ventilation load's pretty good size. So we'll talk more about this in class, but this should give you some kind of an idea. And then as to how to run this program, I would suggest that you go over this and then try to use that file I sent and see if you can get it to run. So these are the psychometric chart. It will plot the state points out. Well, that really looks pretty good. I think this little test came out reasonably well. So with that, I think I'm going to stop at this point. And then I don't know, later this morning, I will record additional video that shows how to move into the realm of chill water and where we input the plants and all of this stuff down here, the chillers, cooling towers, boilers. But this is probably enough for one video. So I'll be back with another link shortly.